Yo guys, hold up. Right now we're gonna go through a question which came in the 2025 GCE ECZ paper. I think I said that right, yeah. Okay, now this question is on optics, and it's testament to the fact that you need to know math in order for you to know physics, because you need some mathematical concepts in order to solve the problems at hand. So let's get into it. Okay, the question reads that figure 6.1 shows a ray of light which is incident from air into an optic fiber which is made out of glass and its refractive index is 1.5. Okay, the light is incident at B and makes an angle of I and then leaves B at an angle of R, and then it continues and says that it then strikes the wall at P and makes an angle of 53 degrees. Okay, now the question further states that calculate angle R, angle I, and the critical angle of the glass fiber. Okay, now we need to calculate the value for R, first of all. Okay, now this is the point where I was talking about where you need to know a lot of math. Okay, not that much, but just a good amount. Like in this case, we need to use some principles of geometry, angles, and all those things. So in this case, we want to calculate the value for R. So if you look at this carefully, we know this is a normal, right? At 90 degrees, so that's a 90-degree angle. And we can just subtract 55 from 90, which is going to give us this angle right here. And if we look at this carefully, these two lines are parallel. The normal and the glass surface are parallel. So which means the angle right here is equal to angle R. Or if you want, you can just say a right angle triangle, and that's a 90-degree right there. We can just add 53 plus 90, then subtract all that from 180 to give us the value for R. But yeah, I'm not doing all that. So here we can just say that R is equal to 90 minus 53, which is going to give us exactly 37 degrees. And therefore R is equal to 37 because that angle there is equal to 37. Take note, these are alternate angles and that's the transverse right there. Okay, next step, calculate the value for angle I, which is the angle right here. So yeah, now this is why we need to get kind of involved in with principles, and we need to use Snell's rule or Snell's law. So Snell's law states that the refractive index of any material is equal to, so we can say Snell's law. So that means the refractive index, this figure, which looks kind of like that. It's kind of an eta, but yeah, kind of like an N. So here we're saying that the refractive index of glass as the ray of light moves from air is equal to sine I divided by sine R. So what we're finding here is the absolute refractive index. So whenever the ray is moving from air into another medium, that's the absolute, or from a vacuum to another medium. We call that the absolute refractive index. But there are certain instances where maybe we might have glass, water, and then tell you to calculate the refractive index. There, you need to use the principle of relative refractive indices. But in this case, we're not talking about that. So here we're finding the refractive index as the ray of light moves from air to glass, which is the refractive index of the glass. So what we need to do here, we just need to substitute sine R and the refractive index to give us sine I. So sine I is equal to just multiplied by the corresponding, which is giving us the refractive index of glass multiplied by sine R. So here we can just say that I is equal to sine inverse of, so what's this here right here? We could tell from the question that that was 1.5, and then sine R, which is the angle that you were being given, which is sine 34, right? Then if you punch that into a calculator, you're going to get something like 36 or no, 30, sorry, 34 point something. But yeah, let's just leave our answers correct to two significant figures. Yeah, so we're going to say that's equal to 65 degrees. And then for the last question, where we want to determine the critical angle. So the critical angle is just the angle of incidence that produces a refracted angle of 90 degrees. Critical angle, yeah, it's equal to 1 over the absolute refractive index. If you really want to know how you derive this, just put a comment saying refractive index and I'll make a video on it. So that's going to be 1 over 1.5, which means our answer is equal to sine inverse of 1 over 1.5. Plug that into a calculator and you're going to get 42 degrees. Yeah, and that's how you deal with those calculations right there. Okay, now for B. It says explain how the ray manages to travel through the glass fiber and leave at the other end of the same fiber. Okay, so what happens is that the ray actually hits the surface of the glass fiber at an angle greater than its critical angle, therefore undergoing total internal reflection. Then for the last question, which reads, state one use of an optic fiber. Okay, optic fibers are used in endoscopes to get images of the human body, or the internal parts of the human body. Or they can also be used in telecommunication to send and receive information. So those are two, but yeah, just write one. Oh yeah, and before you leave, don't forget to like and subscribe and share the video with a friend. Really helps the channel out. Yeah, peace.